In last video, we discussed about conversion of degrees into radians and radians into grades. Today, we are going to discuss about different ratios in trigonometry with respect to right angle triangle. ABC is a right angle triangle at B. Suppose if I am taking theta here, with respect to theta, BC is opposite side. The side which is quite opposite to right angle, we know that is hypotenuse. Then AB is called as adjacent side. Now, in trigonometry, there are fundamentally we have three ratios are there. Those are sine theta, but we have to write it as simply sin theta. And cosine theta, this is simply we can written as cos theta. We have to pronounce it as cos theta. Then tangent theta. We will pronounce it as tan theta. The reciprocals, the reciprocal of sine theta is cosecant theta. We can write CSC theta, or we can write cosec theta. The reciprocal of cos theta is secant theta. We can write SCC sec theta. The reciprocal of tan theta is cotangent. We can write as cot theta. So try to remember, sine reciprocal is cosecant, cosine reciprocal is secant, tan reciprocal is cot theta. Then what is the definition or the formula of sine theta? Sine theta equals to opposite side to the theta, opposite side to the theta. To the theta is nothing but given angle upon hypotenuse. And cos theta is adjacent side to the theta upon hypotenuse. And tan theta is opposite side upon adjacent side with respect to theta only. Here observe opposite side with respect to this triangle which I am showing now with respect to triangle ABC. We can write here it as opposite side is BC upon EAC. Here adjacent side is AB upon EAC. Similarly for tan, opposite side is BC upon EAC. This is by using right angle triangle. By using coordinate geometry 2D, two-dimensional geometry, suppose for example I am taking a point here. For example, I am taking a point P whose coordinates are x comma y. If I join the point P to the origin, this OP is called as radius. If I draw a perpendicular from P2 on x-axis, this is perpendicular. Suppose it meets on x-axis, we can mark it as M. If I am considering this as angle theta, then with respect to theta, PM is opposite side. So can I say that the length of PM is y? Y, it's y coordinate. And can I say OM is nothing but x? If I am considering the radius is r, then with respect to coordinate geometry, can I say that sine theta is nothing but y upon r? That means hereafter remember, sine theta is nothing but y coordinate upon distance of the point from origin. Similarly, cos theta is nothing but adjacent side. Adjacent side is nothing but here OM. OM value is x upon hypotenuse is nothing but r. So we can remember here as x coordinate upon distance of the point from origin. Origin. Here tan theta is nothing but y upon x. That means y coordinate upon x coordinate. I hope it's clear. Now, what about the reciprocals? The reciprocal, sine reciprocal is what? Cosecant theta. So, can I say that cosecant theta is nothing but 1 upon sine theta? So, 1 upon sine theta is nothing but 1 upon sine theta is nothing but what? Opposite side upon hypotenuse. Can I write it as hypotenuse upon opposite side? I hope it's clear. That means we can write it as r upon y. That means distance of the point from the origin upon y coordinate. Similarly, secant theta. Secant theta is the reciprocal of cos. So we can write 1 upon cos theta. But cos theta is nothing but adjacent side by hypotenuse. So we can write here it as hypotenuse upon adjacent side. With respect to xy plane, we can write r upon x. Distance of the point from the origin upon x coordinate. Cot theta, cotangent theta is nothing but reciprocal of tan theta. So we can write it as tan theta is nothing but opposite upon adjacent. So reciprocal is nothing but adjacent side upon opposite side with respect to right angle triangle. With respect to xy plane, x coordinate upon y coordinate. I hope it's clear. Better you have to remember with respect to right angle triangle as well as with respect to xy plane is nothing but Cartesian plane or two-dimensional geometry. Let's see what it will happen. Sine theta into cosecant theta. Sine theta into cosecant theta can be written as 1 upon sine theta. Why? Cosecant is the reciprocal of sine. So we can cancel sine theta and sine theta. We will get 1. That means we have to remember a trigonometric ratio. The product of a trigonometric ratio to its reciprocal is always equals to 1. Similarly, we can say that cos theta into sec theta equals to 1 and tan theta into cot theta is also equals to 1. Now, what it will happen? Sine theta upon cos theta. Generally, sine theta with respect to xy plane is what? Y upon r. That means with respect to right angle triangle, opposite upon hypotenuse by cos theta is nothing but with xy plane x upon r. That means with respect to right angle triangle, adjacent upon hypotenuse. Can we write it as y upon r into r upon x? Can we cancel r and r? So what we got? Y upon x. But y is nothing but opposite side with respect to right angle triangle. X is nothing but adjacent side with respect to right angle triangle. So we can say that it is nothing but tan theta. So please remember hereafter, tan theta can be expressed in sine and cos as sine theta upon cos theta. Now, can we write the sine theta as 1 upon cosecant theta? I am extending the formula 1 upon cosecant theta upon cos. Can I write 1 upon secant theta? So it can be written as secant theta upon cosecant theta. So you have to remember tan can be expressed in sine and cos as sine upon cos. If you want to express with the reciprocal, secant theta upon cosecant theta is also nothing but tan theta. I hope. Observing the triangle ABC, AB length given 3 units, BC length given 4 units. They are asking to find out sine theta, cos theta as well as tan theta. How to find out? Before finding sine, cos and tan, we have to find out hypotenuse. Why it is hypotenuse? Opposite to right angle. We know that by using Pythagoras theorem, hypotenuse square equals to sum of the squares of other two sides. That means side square plus side square. This is by using what? Since by using Pythagoras theorem. Here hypotenuse is nothing but AC square equals to AB square plus BC square. What is AB here? 3 square plus what is BC here? 4 square. 3 square is nothing but 9 plus 4 square is nothing but 16. 9 plus 16 equals to 25. So AC equals to, when you are removing the square, it will get square root. Square root of 25. Square root of 25 is nothing but plus or minus 5. But here AC is a length of side of a triangle. Length never be negative. So we can take AC equals to 5 units. So once we got AC value, we can find any trigonometric ratio. Sine theta. Sine theta is nothing but opposite side with respect to theta upon hypotenuse. That is nothing but BC upon AC. What is the BC value? 4. What is the AC value? 5. So sine theta value is 4 upon 5. If they are asking cosecant theta, just the reciprocal of sine, we can write 5 upon 4. We have to switch the fraction. Now what is cos theta? Cos theta is nothing but adjacent side. AB upon hypotenuse. AC is nothing but 3 upon 5. If you wish to find out its reciprocal, sec theta is nothing but 5 upon 3. Similarly, tan theta is nothing but opposite. BC upon adjacent. AB. BC value 4. AB value 3. If you wish to find cotangent, cot theta, just switch the fraction of tan theta. That means 3 upon 4. This is the way we have to find the trigonometric ratios by using right angled triangle. I hope it's clear. Let's see the next question. If P is a point having the coordinate 6, 8 in xy plane, then find the value of secant theta. We know that to find the value of any trigonometric ratio in xy plane, just to understand very clearly, I wish to draw an xy plane with respect to a circle. So this is my xy plane. Here x coordinate is positive, y coordinate is also positive. So the point lies in first quadrant. Suppose I am taking, this is the point P, 6, 8. Now I join P to origin. this is nothing but radius of the circle. If I draw a perpendicular on x-axis, if I am taking it as M, origin as O, then OM is nothing but 6 units, PM is nothing but 8 units. Now I want to find out OP. We know that OP square equals to OM square plus PM square. Why? By using Pythagoras theorem. So OM value 6 square plus PM value 8 square is nothing but 36 plus 64 equals to 100. This is OP square. If you remove the square of OP, then this right side quantity, that is 100, will get square root. Square root of 100 is nothing but plus or minus 10, but I am taking positive 10. Why? The distance up is never negative. So OP value is 10. OP is nothing but the radius. So R value equals to 10. What do you want now? Secant theta. Secant theta is nothing but reciprocal of cos. Can I write 1 upon cos theta? So 1 upon cos is nothing but x coordinate by distance of the point from origin. So R upon x, you can write directly also. R upon x. What is the R value here? 10 upon. What is the x value here? X value is nothing but OM is 6. If you want to simplify, you will get 5 upon 3. I hope it's clear. In my next video, we are going to discuss about what are the trigonometric identities and some more interested problems on this topic. Okay.